Okay, so we're going to jump into quadratic inequalities. So kind of looking, I suppose, first of all, at just generally that we know what an inequality is. So we kind of know inequality signs are your kind of greater than, less than, all of those signs that you would have done previously, you would have done at junior cert, all of that before. So just making sure you're kind of up to speed with all of that, what all the signs stand for, that you recognize what they all mean, and so on and so forth. And just making sure, I suppose, that general idea of with inequalities, we're not going to get answers of just x equals something, like x equals 7. We're instead going to be getting range, and that's kind of the key word that we have here. We're getting ranges of values. So we might be getting an answer that x has to be less than 7. We might be getting an answer that x is between 4 and 2, and so on and so forth. So we're always getting ranges of answers here in terms of our inequalities. So just making sure you're kind of happy with, I suppose, both of those things before we dive into this one. So looking at a quadratic inequality is going to be an equation, or not an equation, I suppose, an inequality. It's kind of in the name, where the expression we're looking at is a quadratic expression, and we're looking to find where that quadratic expression is maybe less than 0 or greater than 0 or less than a particular value or greater than a particular value. And in order to find this or to solve this or to kind of get our solution set, I suppose, if you like, for a quadratic inequality, what we want to do is we're going to set the quadratic equal to 0. And the reason we do that is we're trying to find the roots of the quadratic. So say, for example, I have a function and it's a quadratic function f of x, and I want to know where it's less than 0. Well, the best place that I can start is where is it equal to 0. So I find the roots of that quadratic first of all, and then by finding the roots, that's going to let me find the places where it's less than 0, because I know where it can't be, but I know kind of, if you like, the maximum value that it can be. So I know the value that it's allowed to be where it's equal to 0, and then I can just make sure that it's not that value. That kind of gives me an upper bound of sorts on it. So when we're looking at these quadratic ones, you're going to be finding your two roots. So remember, with the quadratic, it's generally two roots. So we're going to be finding our two roots of the equation, and then using those two roots then to find the overall answer, the overall solution set. And that's coming back to what I was saying there earlier as well, a solution set or a range of solutions. So instead of just having one solution, we're going to be finding a range of values that satisfy our equation. So if we're looking to find where the quadratic is greater than or equal to 0, we are looking at where the graph is above the x-axis. So we're looking for the y values for which the graph is greater than or equal to 0. So positive y values. So think about your graph, what it would look like if I draw a quadratic here. If I want to know where that quadratic is greater than or equal to 0, I'm going to be looking at where is the graph in this positive section here. Okay, above the x-axis. And I'm looking, when I talk about it being positive, I'm considering the y values there. Where are the y values positive? Because remember, if I think of my quadratic as being a function like f of x and y are interchangeable. And we know that from our junior cert, from our work on functions. So really I'm looking here at, for this one, where is y greater than or equal to 0? So I'm looking at that pink section there. If I'm asked then where's the quadratic less than, and maybe I'll use a different color here, less than or equal to 0, then I'm looking in this bottom section here below the x-axis. So we're looking at where are the y values less than or equal to 0. Okay, so making sure that you know which section you're going to be looking at is again very, very important for all of these questions, that you know if I'm above the x-axis, that's where my function is greater than or equal to 0. If I'm below the x-axis, that's where my function is less than or equal to 0. And making sure that idea, making that connection between f of x and y is really going to help you here in really kind of nailing down which part of the graph we're looking at. But in general, I suppose if we go in general, if they ask you quadratic greater than or equal to 0, you're thinking greater, you're thinking above. If they say less than, you're thinking below. Okay, in simple terms, I suppose. So our steps in solving, we are going to solve to find the roots. We are going to draw a sketch. The sketch is quite important. It can seem like it's not, but it's important to draw the sketch marking in the roots, because remember, the only reason we're finding the roots is to give us kind of endpoints here. And then from our sketch, we're going to identify the values of x that satisfy the inequality. So our solution sets there. So let's just kind of get into it, I suppose, and look at the kind of how it works in practice. So find the solution set of the quadratic inequality x squared plus 7x plus 12. So working that out, first of all, I need to find the roots, because if I want to draw a sketch, I need to have the roots of the equation. So I'm going to let it equal to 0, so that's x squared plus 7x plus 12. So I want two numbers that are going to multiply to give me 12, but would add to give me 7. So that's going to be x plus 3 and x plus 4. So I get x is equal to minus 3 and x is equal to minus 4. Okay, looking at my quadratic here, I can see as well it's a positive leading coefficient, positive coefficient of x squared. So I'm expecting a nice U-shaped quadratic, which has two roots, both negative. So let's just kind of keep our sketch. It is a sketch, but sure, let's try and keep it somewhat accurate, I suppose. So keep my roots to the left-hand side. So my two roots, minus 4 and minus 3, I've plotted those in. Now we need to get to the point where we need to decide which section of the graph we're going to be looking at. And to do that, we need to go back to the original question. Okay, so the original question here was, where is it less than or equal to 0? So remembering kind of what we looked at up here, less than or equal to 0, we're thinking below, we're thinking this section here. So now I just want to make sure that I can mathematically write down what values work for that. So here it's allowed to be equal to 0, so I'm allowed to include my two roots, and we can see we're also kind of working on a kind of continuous range there. So really, my value of x is allowed to be anything between minus 3 and minus 4, including those two endpoints. Because it's less than or equal to, I'm allowed to continue that less than or equal to throughout the question there, throughout my solution set. So really my value of x there could be anything between minus 4 and minus 3. And I know I'm down in that below the x-axis part because my inequality was less than or equal to 0. So remember, we're thinking of our quadratic as being the same as like a function f of x, and f of x is the same as y. So we're looking at the negative y values. Where are my negative y values? Below the x-axis. But that's the general gist of it, okay? And these sort of questions then, your quadratic inequalities come up then in a few of your other types of inequalities. So that's kind of why it's important to make sure we have these ones off well. Let's just apply the same idea for the next one. So first of all, I'm going to let it equal to 0. That's going to let me find the roots, which are going to let me then draw my sketch of my graph. And in doing that, then I'll be able to better kind of get a sense of where my solution set is going to be, whether it's going to be maybe above the x-axis or whether it's indeed going to be below the x-axis. So looking at my solution set here, I'm going to be factorizing. So let me see, I'm just going to put down our answer here for our factorizing. Factorizing quadratics, I suppose we should be able to do fairly well at this stage. So 3x minus 5, 2x plus 3. So that's my solution set at the moment here. So taking that now, that gives me x equals 5 over 3 and x equals minus 3 over 2. So those are my two x values. Those are my two solution x values. Those are my roots. Now I don't want the roots. I want to know where my function is greater than 0. The roots would give me where it's equal to 0, but that's not what I want. So again, sketching my graph. Doesn't have to be any work of art, just a little sketch. So minus 3 over 2, we'll keep one root to the left, one root to the right, because one's negative, one's positive. Just keeping it somewhat, I suppose, consistent with the question. And this time we need to know which part of my graph I'm going to be looking at. So let me kind of keep it consistent with the highlighting here. I'm looking at greater than 0. So greater than 0, greater than, above. I'm looking above the x-axis. So that's going to be these two endpoints here. So what this means for me, if you even just think about kind of what it means here, the values, say on the left-hand side here that I'm including, would be values like minus 2, minus 5 over 2, minus 7 over 2. Okay, values that are smaller than my minus 3 over 2. So I'm allowed to include values less than minus 3 over 2. Similarly, on the right-hand side, I'm allowed to include values that are greater than the 5 over 3. So in this case, when I'm looking at the two endpoints, my inequalities don't really overlap in the same way as they do when we have that continuous range. So when I have my two endpoints here, I can use those kind of split inequalities and just state my two ranges that I have. Making sure here as well that we're not including the equal to line because it's not allowed to be equal to in this one. It's only allowed to be greater than 0. Okay, so we're going to get a lot more practice of these as we go as well. So let's look at this next one here. Again, same steps as before. We're going to let it equal to 0. I get 2x squared plus x minus 15 is equal to 0. So let me see. So getting my factors for that. So 2x minus 5, x plus 3 equal to 0. So that gives me x is 5 over 2, or x equals minus 3. I then just draw my little sketch here. And again, it is just a sketch. You can see I'm nearly drawing the exact same picture every single time. All that this sketch is supposed to do is help me decide where in my graph I'm looking. So looking at the quadratic that I have here, it's greater than or equal to 0. So I'm going to be looking at my two endpoints here. So x is less than -3 or equal to, and x is greater than or equal to 5/2 as my two answers there. Okay, and if you're unsure, it can be helpful maybe sometimes to try out a different value. So if you wanted to, you could pick a value within your solution set there. So say I take my graph 2x squared plus x minus 15. I look at my solution set. Well, I've said that if something is less than 3, it should work. So let's try one. Let's try -5. So we type in -5 squared plus -5 minus 15, and I get an answer of 30, which is greater than 0. So that suggests to me that yes, I have done something correctly here. So it is again possible to check your answers here. Just pick a value within your solution set and sub it into your function and see, does it satisfy the inequality there. Let's look at another question. So this one's from a Leaving Cert ordinary level paper. Now it is 2004, so it's a fairly old one. So p is a positive number and f is a function f of x equals 2x plus p x minus p. Given that f of 2 equals 0, find the value of p. So kind of pulling in a little bit of your functions here, we're subbing in 2 for x and noting as well then that my answer here is 0. This should all be equal to 0. So I have 4 plus p and I have 2 minus p equals to 0. Now we hopefully recognize this part as kind of that end part of your quadratics where you have your two factors. So I take each of those, put them equal to 0, and I get an answer of p equals -4 and p equals 2. Looking back at the question, they've told me p is positive, which means it's not allowed to be -4, and it must be 2. Okay, so again, the good trick there of making sure we read the question to make sure we're answering the question that we're given, not just giving two solutions, because in fact for this question p only had one possible value. Hence find the range of values for which f of x is less than 0. So let's just set up my function f of x first of all. So it's 2x plus 2 and it is x minus p, or x minus 2, excuse me, x minus 2. Okay, I want to first of all get the roots. So the roots would be where this is equal to 0. So where my 2x minus 2, 2x plus 2, and my x minus 2 is equal to 0. So x is going to be -1 or x is going to be 2. So again, I sketch my graph, same sketch every single time. And now I just need to make sure, double check the solution set, the area of the graph I'm going to look at. I'm looking at less than 0. So I'm looking at this continuous section underneath here. So x is allowed to be anything between 2 and -1. That's my theory here. If I want to test it, I can pick a number within that range. So a number like, well, we could even try 0 here because 0 is within that range. So let's type in 2 times 0 minus 2. Put my brackets in. And 2 minus 2, and I get an answer of 0. Okay, I get an answer of 0, which works out for me there. Okay, so I get an answer of 0. Okay, so just again making sure that we are kind of solving our question correctly there. Okay, that we're following everything through as best we can, and making sure that kind of everything works out for us there, I suppose, in that sense. Okay, making sure that the solution set that we get is going to satisfy the inequality that we have. Okay, so fairly straightforward there, I suppose. Let's just see. Okay, so we've no more questions on the quadratic ones. What I'll do is maybe we'll do the rational ones in a separate video then, just to kind of build on what we're doing here in the quadratic ones.